All right, so today we're going to be talking about right triangle trig. So some of this should be a refresher from your geometry course last year. So you remember this saying, oh, sorry, the cord's getting in the way. Let me move that. Maybe I'll move it. Okay. So the saying SOHCAHTOA right here. So sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. So right here we have sine is opposite over hypotenuse. This is adjacent over hypotenuse. This is opposite over adjacent. Now, three new ones are the cosecant, secant, and cotangent, and they're just the reciprocals of the ones above them. So cosecant's reciprocal is sine. The way I remember it is S and C, C and S. They never match. They're always opposite of each other. So don't ever put S and S together. Those aren't reciprocals. So hypotenuse over opposite. This is hypotenuse over adjacent. This is adjacent over opposite. So what you're going to need to do is you're going to need to use Pythagorean theorem. Remember that a squared plus b squared equals c squared to find your missing side. Then we're going to label everything OHA and then just fill out our trig functions. So right here, to first figure it out, you're going to do 3 squared plus 4 squared equals c squared and solve that. 9 plus 16 equals c squared. That's 25 equals c squared. So c equals 5. So I'm going to put a 5 up there. Now from my angle, I need to label everything. So the 5 is across from the right angle. So that's called my hypotenuse. The other side that makes up my angle right here, you see here's the other leg? That has to be adjacent. So the other leg that makes up your angle is always called the adjacent, which makes this opposite, and it's across from it. That's why it's opposite. So then you would just write out, make sure you write sine of your angle, because it's not just sine equals, and it's not just sine fraction. It's sine of some angle equals, tangent of some angle equals. So this would be OH, AH, and OA. And then write my other reciprocals back here. So this is 3/4, this is 5/3, this is 5/4. So go ahead and pause the video and see if you can find your missing side here, and then come back and see if you're correct. Make sure you pause it, you cheaters. I love you. All right, hopefully you came back and you found out this was 12, because you should have done 5 squared plus x squared equals 13 squared, solved it. You should have gotten 12. So then we're going to say, oopsie, sine of my angle, cosine of my angle, tangent of my angle. Now make sure you label it. Here's my angle. So here's the right angle down here. I should have marked that on your paper for you. Here's the right angle, which makes C the H. So the other side that makes up that angle right there has to be the A, which makes the 12 the O. So we're going to say OH, AH, OA. And then you flip them for your other reciprocals over here. So 13 over 12, 13 over 5. Okay, down here when you're doing a point, your radius is always going to be positive. So this is just like your A and your B. So if I had it like this and I went over 8 and down 6. So here's over 8 and down 6. And there's my angle. So we're going to say, that you do a squared plus b squared equals c squared. That should be 10. I don't know, I'm thinking it's, so do a squared plus b squared equals c squared, and you get square root of 100. So then we're going to label this as my adjacent, my opposite, and my hypotenuse. So then you're going to do sine of my angle All right, so make sure you guys are trying to fill this out on your own. So pause the video if you need, and then come back to make sure you're right. So you can leave them unreduced. This does reduce to -3/5. This is 4/5, and this is -3/4, and then you flip those. They would reduce it on the ACT and stuff, and the negative just goes wherever. So right here, if I do the 0.01 up 3, so over 1 up 3, so that makes the hypotenuse here the square root of 10. So this is O, H, and A. So if you see your A is always the X value, and your O is always, this is always your adjacent, and this is always your opposite side when you draw these things. And that will be true every time because of the way you draw your angles. Let's see, O, A. You could rationalize this, and you'll see that sometimes written this is 3 square root of 10 over 10. I'm fine unrationalized. The ACT would rationalize it, and some of your teachers next year might make you rationalize it, but I don't think there's a purpose to rationalizing it. All right, so down here, setting up your right triangle trig to solve these things. So first, if this is a 90 and that's 60, we know this angle down here is 30 degrees. Let's call this like Z because it has to be something different. So that's 30 degrees. Oh, you know what? I need to give you a side for this. Well, we're going to make this side over here 3. I see I now have a mess up. So if this side is 3, I know this is 6 and this is 3, radical 3. But I'm going to go ahead and prove them to you. This is just a special right triangle, which is what we're going to learn in a different section. So this right here, I know that across from my 30, I'm just going to use the 30 degrees here. This is my O, this is my H, this is my A. So now I'd have sine of 30 equals 3 over my Y, and then I'd do cosine of my 30 equals my X over my Y. All right, so if I solve for Y here first, this gives me 3 over sine of 30. So if you type that in your calculator, 3 over sine of 30, it's going to tell us 6. Oh, what do I have it in wrong mode? Let me change it over to degrees. 6. So that's why Y is 6. And I can change this to a 6 right here. So Y equals 6. And then if I do 6 cosine, not 6, it's, 6 cosine of 30. That is the same thing as 3 times the square root of 3. See, and you're going to learn how to do that too. So you can write approximately 5.2 if you'd like for now. The next one has nothing special to it. So I'm going to say this is my O, A, and H. So if I do sine of 19, that gives me X over 13. Cosine of 19 equals A over 13. So multiply that over. So we're going to get 13 sine of 19. That's our X. And 13 cosine of it. And there you go. There are 2 values there. Why I say this is my A, this is my Y. Sorry, Y. Down here, if we want to do this, what we're going to need to do is you can draw your just draw your right triangle. It just tells you that it should say with angle C is 90 degrees. So this is C, we'll just label that A and B. So this is 24 across from big A is little a. And you also know there's a B and a C here, so it's missing a A. Like every side, this is AC, so it's missing a little B. AB is missing a little C. So what I have here is I have the adjacent side. So if I do cosine of 24 would equal 8 over C. When I cross multiply, it ends up being a division problem. So C equals 8 over cosine of 24, which is approximately 8.76. And then you could use Pythagorean theorem from here. If I use this number in there, I could do C squared minus A squared, and then square root that number. That could also give me the answer. So little b is about 3.56. But make sure if you're going to do it this way that you use the entire number like I did. I didn't use 8.7. I used the entire number squared. This is 19 and this is 4. So again, I have adjacent. So I could do cosine of 19 equals 4 over my h, which is little c. It's going to be a division problem again. So 4 over cosine of 19. So c is about 4.23. And then I'm going to show you if I do it this way, minus 4 squared. Square root that answer. So little a is about 1.38. I'm going to show you if I use the other function too. So if I did tangent here, I could say tangent of 19 equals my little b, or little a, I mean, over 4. And if I did 4 tangent of 19, look, exact same decimal. So either way you can get it. Okay, down here, if I'm trying to find an angle, I'm going to use the inverse button. That's these buttons up here. See where it says like the little negative right there? That's what the angles are. So this right here, I have opposite and adjacent, so that's tangent. So tangent of x equals 9 over 5. So tan inverse it. So you did second tangent and 9 over 5 will give us our angle. So x is approximately 60.9 degrees. So this one right here, I have opposite and hypotenuse. So I'm going to do sine of x, 7 over 13. So x equals, so the way you would write it is sine inverse is 7 over 13, which is approximately, let's see, 32.78 degrees. Let me move that over so you guys can see it.